Hello. In this lecture, we're going to learn some additional equation solving techniques, right? And the one we're going to do is solve equations with radicals or square roots, right? So an equation with radicals is going to be something that looks like this, like x equaling a square root or some form like that. And the steps are actually quite simple, but the process can be a little difficult. So that's why we're going to go through this. So really what we want to do is isolate the radical, right? The radical may not be by itself. We want to make sure it is. The easiest way to get rid of a radical is just to square both sides, right? In this case, we're allowed to square a radical because we have another side that we can square, right? If I'm going to square a radical, I have to square the other side, right? We're going to solve for x using any methods we can. And one thing that we're going to do that might be a little different is we're going to have to check our answers, right? This actually might be kind of a new case of checking our answers, but by squaring it, we actually get rid of some of the restrictions in the problem. So some of the answers we might get are kind of false answers. So let's look at that, right? So here's our first problem. We can see this is already isolated for the variable, right? It's already on one side. So to get rid of a variable, I'll just square both sides. Look at x squared is equal to, when I square a square root, they cancel. I get x squared equals x plus 2, right? This is a quadratic. I have an x squared, an x to the first, and a constant. So when we solve a quadratic, what we want to do is we want to just bring everything over. Minus x minus 2 is equal to 0. And we can solve by any of the methods used in section 1.5. And so in this case, we're going to factor. X minus 2, x plus 1 is equal to 0. And I get the values of x equaling 2 or x equaling negative 1. But we want to make sure we check our answers. And so what we mean by checking our answers is we're going to take each of these, 2, a negative 1, and plug them back in and make sure we get a true mathematical statement. So let's start with 2, right? Let's start the x equals 2 case. So what I'm going to do is I'm going to plug it into my original equation. 2 is equal to the square root of 2 plus 2. 2 plus 2 is 4. 2 is equal to 2. And this is what we call a true mathematical statement, where we have something that's obviously true. 2 equals 2. That tells us this, yes, in fact, this is going to be a solution. Let's look at the x equals negative 1 case. Negative 1 is equal to the square root of negative 1 plus 2. Negative 1 is equal to the square root of 1. Negative 1 is equal to 1. This is what we'd call a false statement, right? Something that's not true. Negative 1 is not equal to 1. We could also stop at this point because we have a negative number equaling a square root, which cannot be true. So we know, in fact, this is not going to be a solution, and the only solution we're going to have is x equaling 2. Let's work on solving a different, slightly more difficult case. Here, we see we have two radicals, right? We have this radical and that radical. And when we solve it, we don't want to put them on the same side. It's actually quite the opposite. When we solve a radical like this, where we have two of them, I actually only want one on each side, and we'll see why. Right? What we're going to do is we have the first radical isolated, and we can square both sides. Right? When we square a radical by itself, all we get is what's inside. If I'm going to square this radical, here I'm going to have to FOIL. Right? 1 plus 2 root t, 1 plus 2 root t, and when I FOIL, right, I get 1 first, outer, plus 2 root t, inner, plus 2 root t, and last, plus 4 root t squared. And because I have a root t squared, right, this 2 root t is just 4 root t. Because this root t is being squared, root t squared, that just becomes 4t. Right? But I still have one radical. So we can pretty much start over now that I've squared the equation once, I got rid of one radical. I can work on this, isolating for the radical and solving this equation again by eventually squaring, right? So to isolate for this radical, I'm going to want to subtract 1 and subtract 4t to both sides. I'll get t plus 3 is equal to 4 root t. Right? I can divide both sides by 4. T plus 3 over 4 is equal to root t. Right? Now I'll square both sides. T plus 3 quantity squared over 4 squared is equal to t. Right? T plus 3 squared over, let's see, 16 is equal to t. And now when I solve it, I can use it kind of any other algebra thing I want. So I'll cross multiply. T plus 3 squared is equal to 16t. Here, when I square this, I can't distribute, I have to FOIL. T plus 3 times t plus 3 is equal to 16t. When I FOIL, my first, my outer, my inner, and my last is equal to 16t. T squared plus 6t plus 9 is equal to 16t. I'll subtract 16t, and I'll get t squared minus 10t plus 9 is equal to 0. And again, I can solve this quadratic really any way I've learned in section 1.5. Here, this is a nice little factoring problem. T minus 9, t minus 1 is equal to 0. And my two values are t equals 9 and t equals 1. But again, I want to look at my original problem and say, if I plug them into here, will they both work? So that's what we're going to do. We're going to check t equals 9 and t equals 1 for my original problem. Right? So we need to check our two values of t equals 9 and t equals 1. So we'll start by doing that. So the t equals 9 case. 5 times 9 plus 4 minus 2 root 9. And I want to make sure that that is actually equal to 1. So 5 times 9 is 45 plus 4 minus 2 root 9. Still want to make sure that's equal to 1. 49 minus 2 root 9. So the square root of 49 is 7. The square root of 9 is 3. 7 minus 6 equals 1. Yep, that's a true statement. I'm good, and I know that that is going to be a solution. So I look at my t equals 1 case, and I want to plug it in. 5 times 1 plus 4 minus 2 root 1, and I have to make sure that that is equal to 1. Right. 5 plus 4 minus 2 root 1 is equal to 1. Root 9 minus 2 root 1 is equal to 1. So root 9 is 3, root 1 is 1, so 2 times 1 is 1. So yeah, that works out. So in this case, we actually get both solutions, t equals 9 and t equals 1. And that's how we solve a slightly more complicated case. All right, hopefully this helped, and I will see you in class.